Hello everyone, welcome back to our NDT training session. I am Mutalakshmi Kanagaraj, quality expert, and today we are discussing about the longitudinal fields. Let's start our session. First point is induction by coils. In the principle, longitudinal magnetic fields are created when current flows through a coil made of non-magnetic conductors, example copper wire, wrapped around the test object. This is a principle. The next one is magnetic field is strongest at the coil surface. The magnetic field forms both inside and outside of the coil with maximum strength at the inner surface of the coil. For effective magnetization, the test object should be placed close to the coil's inner surface, so that is exposed to maximum flux. And the coil techniques are suitable for objects of different shapes and size. Complex parts can also be inspected by adjusting coil position or number of wraps. Multiple coil wraps may require to achieve sufficient magnetic flux density. So, increases the number of coil wraps, increases the ampere turns. That means current into number of turns, which increases magnetic flux density. Sometimes multiple wraps are required for adequate magnetization. So, these are the points of induction by coils. The next one is field strength and direction. Field strength. Strongest at the surface of the test object closest to the conductor. Weakens as the distance from coil increases. For deeper penetration, DC or half wave DC is more effective than AC, which mainly affects the surface due to skin effect. In DC coils, it determined by the direction of current flow of the coil, that is right hand rule. In DC coils, electrons flow from negative, that means electron emitter, to positive electron collector. The magnetic field direction follows this current path, ensuring a longitudinal field through the object. In AC coils, the direction alternates continuously, giving strong surface magnetization but shallow penetration. In this picture, when the electric current flows through a coil, this is a coil, through a coil wire wound in loops, it creates a magnetic field. The magnetic lines of force, this is a lines of force along the length of the coil. This is called the longitudinal field. The field is strongest inside the coil. So, the test object should be placed there for inspection. The more turns of wire or the more current, the stronger the magnetic field. The next topic is yoke magnetization. This is the yoke. It's like a temporary horseshoe magnet made from soft iron. It is energized by a coil. The electric current flows through, producing magnetism. The two legs, these are the two legs of the yoke, act like a magnetic poles. The first point is when the yoke legs are aligned with the length, of the object, the magnetic field flows along the object. It's useful for detecting cracks that run across transverse the length of the path. When the yoke is reoriented, the field flows across the object. It's useful for detecting cracks that run along the length, that means longitudinal field of the part. So AC yoke, already we see the temporary horseshoe magnet. It's made of soft ions. Have low retentivity ion. It's energized by a coil. In AC yoke, it creates a strong surface field, best for surface cracks detection, fluorescent or dry particles gather at the crack opening. In DC yoke, it produces a deeper penetrating field. So it detects the subsurface discontinuities and flaws under the surface. Yokes are very portable and widely used in weld inspection and field applications because they are quick to set up. The next topic is the primary detection. In longitudinal magnetic fields are excellent for detecting transverse discontinuities. That means if the crack runs across, that means perpendicular. This is the longitudinal magnetic field, then the crack is perpendicular, this is the object, perpendicular to the main axis of the object. The magnetic leakage field will form clearly. Example, a pipe is inspected with the longitudinal magnetic field. This is a pipe, this is a longitudinal magnetic field, will reveal a crack running around its circumferences. So next one is applicable current types. Both AC and DC can be used with longitudinal magnetization. AC current used to detect the surface cracks due to skin effect. DC current, it penetrates deeper, it's allowing a detection for subsurface flaws. The next one is selection consideration. The choice between AC and DC, it depends on the shape of the test object. That means it's a solid bar or a hollow tube or plate and etc. And the type of defects expected, like surface or subsurface. Next one is inspection requirements, sensitivity or penetration. For example, for thin plate, AC is enough because in thin plate surface flaws are mostly detected. For thick components, DC is preferred to reach the deeper flaws. So the longitudinal magnetization gives us the best results when we want to catch cracks running across the part. We can use both AC and DC, but our choice depends on the object size, shape and whether we are after surface or subsurface defects. So I hope you are all clear in this topic. So we will see the next video. Thank you.